Okay, here's what's going on here. This function right here is actually a standard equation for vertical motion of an object in meters. And this negative 4.9 has to do with the acceleration due to gravity. This 241 is called the initial velocity. Since it's positive, that means there was a thrust upward. Since we're dealing with a rocket, that makes sense. And the initial height is 402. In other words, if you put 0 in for t, you get 402. So this is where the rocket started at time 0. It was probably on some kind of platform, got fired into the air, reached some kind of height, and then gravity took over, turned around, and it fell to Earth. And we want to know how long it took to get from here to ground level when it splashed down. Okay, so really we want to know when is the height 0. So this is the equation we want to solve right here. Now it doesn't look like it factors, so it looks like we might have to fall back on the quadratic formula. And I've used Desmos to set up the values for A, B, and C. And there's the quadratic formula. If I say the opposite of B plus the square root of B squared minus 4AC all over 2A, I get an x value of negative, which means if we were just graphing the parabola, it probably started over here. That's one of the roots. But if I use the opposite of B minus the square root of B squared minus 4AC all over 2A, I get this 50.79. So this is 50.7, I'll just say 50.8. That's about how long it took the rocket to hit the ground. Now, how can we find this vertex? How high is it above the ground at its highest point? Well, one way to do that is to find the axis of symmetry. And there's two ways to do that. If you average these two roots, negative 1.6 and 50.8, the axis of symmetry is halfway between those roots. So you could do it that way. The other is to use the formula that the axis of symmetry is the opposite of B over 2A. And then plug that number into the h function to get how high it is at that point in time. And here's what that looks like. If I average the roots, I get this number. And if I plug that number into the h function, I get that ugly looking number. Here it is in decimals. And here's the actual height, maximum height of the rocket. And if I use the opposite of B over 2A, you can see it's the same number. This x equals the opposite of B over 2A is the equation of the axis of symmetry. And if I plug that number into the h function, I still get that maximum height. There you go. Hope that helped. If you have any questions, post a comment.